Welcome to the Grokking Fulcro video series. I'm doing this series as really, it has multiple purposes here. I'm one of those people who really likes to see how things work internally that I work with. I like to understand the primitives that I'm working with, and I find that that makes better software developers just in general. When you're in the mode of just using something and not understanding it, you can get things done, but you often do things in very strange ways that hurt you in the long run. And I also want to just I guess another purpose is to dispel some of the myths around Fulcro and how it works. And I just want to help Fulcro users, do a better job of building their applications. So on that note, part one, I'm going to walk through a bit about the low-level React integration with Fulcro. So Fulcro is a library that allows full stack web app development, but it's not too hard tied to React itself. I mean, React is the central library underneath that does the rendering for both native, web, Electron, like whatever deployment targets that React supports. But you can actually hook in custom rendering and allow Fulcro to render through other things. But in this video, I really want to concentrate on the specific React integration. I want to give people a little better understanding of React, how it works, how using Clojurescript is a bit of a superpower compared to the regular raw React/JS ecosystem. And so, yeah, I just want to show how a number of those pieces work. So I started a project, and I just did an npm init basically, and made a package JSON, which then I added React and React DOM to. Now I prefer using the Shadow CLJS build tool, which essentially, I didn't mean to double click on that. No, thank you, Xcode. Which essentially just acts as an interface between npm and the main Clojurescript compiler. So the Clojurescript compiler is the thing that converts Clojurescript, the language, into JavaScript, the transpiler. And Shadow CLJS is a tool that adds some layers on top of that to make it more seamlessly operate with npm. And I actually will cover a little bit of what Shadow is doing as well, so people can understand a little better what they're doing when they configure it. So I've created a package. I've also created a Shadow CLJS Eden, which I'm probably going to have to show you over here. I think I'm in the wrong directory to do that. And so this one's really simple. I'm telling it to use deps for dependency management, which is a Clojure tool, deps, tools deps. And you can get that on Macs by doing a brew install Clojure. And there are packages for Linux, and you can get it in Windows as well with a little bit of work. Windows Subsystem for Linux, of course, works pretty easily. And I've configured this to do a build for the browser where I'm wanting it to output to the subdirectory public, and I'll get to some more of these pieces here in a minute. I want to make a dev HTTP server on port 8000 that serves that directory, and then I'm asking it to create a network REPL port where I can connect to the browser and send Clojurescript commands through the compiler to the live browser tab to run. And I want to put that on a specific port so I know where it's at. But basically this just lets me say which Clojurescript file to look for kind of the entry point of the application, and then Shadow kind of figures everything else out from there for me. The deps file is really pretty straightforward as well. I've got Clojure, Clojurescript, I've got Fulcro on there so I can show you Fulcro stuff, and then I've got Shadow CLJS as dependency, and I would typically make this a bit more separate and customized, and there'd be a lot more in here, but this is sufficient. And then I've told it source main is the directory I'm going to use in the project, and you saw that, out here in the Finder. Source main is where I'm going to put source, and then demos a package subdirectory, and then these are Clojurescript files. But let's start with a really simple exploration. Let's look at this raw HTML file that I've made. And all I've done here is I've used CDNs to pull in React development and React DOM development, just as straight script tags. I made a style class for red just to have one. I made a div and gave it an ID. So just really plain HTML stuff, and I'm just going to tinker in JavaScript for a second. So let's open this page and let's open the developer tools. And so notice I've got nothing on the screen because there's really nothing there. And I'm just going to say var root equals document dot get element by ID app. And I'm just going to get that div that I had labeled, well, you saw it in the terminal window here, that div I had labeled, right, or given an ID. All right, so now if I look at root, I've got that div. Now React has this concept of a virtual DOM where it creates sort of a picture of what you want the DOM to look like. Then it reifies it in the real DOM, and then when you tell it to update, it goes and compares what it kept with what you want. So let's do a quick little fun thing. Let's say React DOM dot render. So this is the one that understands how to render React things into a browser, and it takes an element. Well, there's React itself has the create element function, and create element takes the type of thing you want to do. So let's make a div, the props that you want to pass. So let's pass let's pass a map from class name to red, because we have that class name we could do, and then children. So I'm just going to give it a string of hello, and then render takes an element, and then it also takes where you want to put it. Oh, I forgot something. Missing a parent. Parent. It's funny. Play with. All right, I'm doing something stupid. Open. Oh, you're writing JavaScript, Tony. Put some commas in there. All right, so there's the children, and then container. Container is root. There we go. So now hello's on the screen. Now if I go and look, this is the interesting part. If I go and look at root, remember that's my DOM element, now it has React stuff on it. And if we play for a second here, let's see now, React root container, current, I think, not current, oh, internal root, yep. And then there's, I think, a current node in here, right? I'm just walking through like what React just attached, right? It went to the thing I told it to render onto, and it attached its kind of copy of what it wanted to look at. So if I look at this current thing, it's a React fiber node, and it has a child that is a div, which has let's see now, div, oh, here we go, memoized props. Oh, I accidentally sent the oh no, that's right, children is that. It's easier sometimes to explore by clicking through here. Current child got the class red. Oh, I think it would end up, let's re-render that. It would end up doing this a little more like what I expected if I made this a list of children. Oops. All right, so we've got our div, our memoized props, our pending props. Well, you get the idea. I thought we were going to be seeing something a little more than this, but I've forgotten. It's been a while since I've wandered around the internals here. Oh, there it is. There's our text node. There's our text child fiber node. Okay, so I expected the hello to be in there. Okay, so you get the basic idea there. So if I go and I say, you know what, I want to change the children to hello there, React doesn't have to delete the node that was already there and put a new one in there, it can look at this tree of stuff that was rendered last time, figure out what the difference is, oh, the string changed, and just change that one node, and then just update that one piece of the real DOM. Now, when you use JSX and something like Webpack, which runs the JSX cross compiler, you can sort of embed this as HTML in your JavaScript code, right, your JSX files, and essentially this syntax in JSX turns into this React create element call. So that's basically how that cross compiling works. Okay, now we could play with this in Clojurescript and see what that interrupt looks like. So I'm actually gonna re-import the project because I cleaned it out so the tree would look clean there. And I'm going to import this deps file into IntelliJ with cursive installed. So I have the cursive plugin installed for doing Clojure. I'm going to tell it's a project, and it's going to pull it in, figure out the dependencies, and I'm off and running. Now, there are a couple things I want to set up here. One, I need to run something like yarn to install my node modules. So now I've got node modules. And then I need to start Shadow CLJS. I'm going to start it in server mode so that I've got something that can compile my Clojurescript. And I'm going to take us to this raw namespace. Now, Shadow starts up a web page for itself, so I can go in here and I'm going to pin this tab. And I can go to the builds and click into this build and click watch, and then I'll start compiling my build. Now in my Shadow CLJS configuration file, I've told it just to include the demo raw so far. And demo raw, you can see, does nothing but define an empty namespace. So really, I've not really given it much. Now the other thing I told Shadow to do was start me a regular HTTP server on this port, and if I go here, it will do a nice thing, and I can go to the elements here, and I can see it loaded my index.html file, which I have the same class in it, but I added this additional script load of the output of Shadow CLJS itself. So you can see in my console, when this page loaded, it said Shadow CLJS is ready. So Shadow CLJS actually connects with a WebSocket. Oh, I don't have the log here. Let me reload this with this turned on, and I can tell it to show me the WebSocket things, and you can see this connected to localhost 9630 via WebSockets. So I've got this live connection that I can talk to the page with. Okay, so I'm going to go up here and add a configuration. I'm going to say I need a remote REPL for Clojurescript, and that's an in-REPL, and it's on localhost, and I explicitly configured it to be on 9000, so it would just always be in the same place and I'd be able to find it, and you can see it reported that here. Okay, so I'm going to start with this REPL. Now this connects me to this running Java process, right? That's the one with the network port. So I have to tell this Java process, which has a number of runtimes, right? I could be running five different compiles and 5 different applications and 5 different tabs. So it's got the idea of, okay, I've got an app running on a browser that's Chrome, and I could open up Safari, and I could say localhost 8000 index.html. I guess I don't need to type that in. And this will load the same page, and now this will see I've got an app on Chrome and an app on Safari. So I could connect to either of these browsers via the REPL. I'm going to quit Safari, and you see it cleans it up there. So here I have to say, Shadow, I'd like you to connect to the REPL for app, and it tells me, all right, you selected app. All right, now in this demo raw namespace, I could say, define a function that takes a single variable and just returns it. All right, that's silly. I'm going to save that, go over here, and if I look at the console, you'll see it just hot loaded this file. It just reloaded it via the WebSocket. So now I should be able to go, the way Shadow and Clojurescript in generally sets this up is the same way Google Clojure with an S sets things up, is this package becomes a dot separated object in the JavaScript land. So I'll find a demo object that has a raw object that has an f function in it. So demo dot raw dot f of 5 is 5. Okay, so that's straightforward. And notice this, this just hot loads. I don't have to reload the browser. Let me say I want to increment y. Go over here, wait for it to hot load. Now I should be able to find a g of 6 that returns 7. Okay, great. Now let's play with the interop in React here. So this raw namespace, I didn't load React. There is no React here, right? I can say React dot. It's got React Dev Tools, which is a browser plugin, so that's why I'm finding some things. But if I try to recall this thing, right, it's like, yeah, you don't have React. So I'm going to say require, and I'm going to do it old school way first. Include CLJS React and CLJS React DOM. These in Shadow, these are kind of legacy ones. Even the stock Clojurescript compiler doesn't recommend you use this anymore, but these were legacy ways of mapping non-Google Clojure libraries into a format that Clojurescript could understand. And Shadow does it automatically through integration, and these are sort of, when you use these, Shadow actually makes little stubs of them, and all it does is does its own thing, which is that you could just use require on a node npm kind of dependency, and then it uses this Goog export symbol to put the React global symbol back into where you expect it, so that sort of you got this legacy style support of there's a global. Without that, if I just say require React, let's just do that first. If I just say require React, you'll see that Shadow injects the React development library for me. It reloads my raw CLJS, but if I go looking for the core React stuff, it's still not there. Right? It's just nothing. And the reason is it actually puts it under an internal node, like module React index thing that that gets it out of the global namespace. So Shadow's trying to help you out here with conflicts. But I'm doing it the old school way first, just to show you that this idea of what we were doing over here, right? We were saying, well, let's define a function called render that takes an element, and then in Clojurescript that would be render on JS doc. Wait, we need a root. So let's def root. We already know what that is. That's get element by ID on JS document app. Right, let me clear that so it doesn't. So I'm just going to save that, let it hot code reload, and then I'm going to show what the value of root is and see it's that div element. So I didn't even have to run it. I just said hot code reload, and because it was a def at the top level, when that file loaded, it automatically evaluated. Now I've got root. So I'm just going to make a quick render function that can say what I did in the REPL over here, right? I want to call React DOM render. So JS / React DOM dot render, and I need to pass it the element and a root. Okay, so now I've got a quick and easy way of rendering something exactly the way I would over there in the JavaScript prompt, just with Clojurescript notation. I'm going to get rid of these functions. And so then I'm going to try that render. Let's put this in a comment so I can explicitly try it. I'm going to try that render on JS React create element. And create element, if you remember, takes the kind of thing JavaScript props, JavaScript children. So I'm going to make a div, and here I don't need the commas. I'm going to need the props. Now these have to be JavaScript, so I'd have to put this #JS in front of this to say convert this to JavaScript props. so that it doesn't try to send a Clojurescript map, which is an immutable data structure defined by Clojurescript that React knows nothing about. And then for children, same thing. I'm going to have to say this is a JavaScript array, not a persistent, immutable vector from Clojurescript that has hello in it. So I'm going to save that. I'm going to let it hot code reload, and then I'm going to run that, and you see hello show up over there. Okay, great, wonderful. And from here, you can see that I can just do kind of raw functional building up of things. So I could do things like, all right, well, I could define a function called div that takes some props and some children, and then does this thing, right? Okay, well, that renders a div, and now props, I'd like to be able to send in a nice Clojure map, and then children, I'd like to do the same thing with children. And so then down here I could say render a div with class name red and children, and notice I'm having to, I guess what I could do here is say, let's make that a variable number of children, and then let's go ahead and pre-turn that into a vector, because that could be a lazy sequence, so I want to be careful that I convert it to something that ends up being what I want it to be. I think that would work okay with a lazy sequence, but let's just be ultra careful with it. And so now I can say hello, save that, let it make my div function. Oh, let's render hello there. So I'm doing but in the comment block here, I'm just sending this entire expression. You can see it popping into the REPL over here. I'll clear that out. So it's calling that function for me. Okay, now what are the problems with this? The major problem is that in order to get the convenience of using Clojurescript data structures, I'm essentially ending up with having to do this conversion, and this creates some overhead. Now, in terms of just how React works, you can see how we get to kind of motion on the screen. I did want to mention this, right? So the idea is I've got a way to say render a frame, render a frame, render a frame, and it's efficient. Even if the DOM is very complex, this is a complex tree of elements. When I say render, I get to say render the whole thing, render the whole screen of stuff. If I had let's say I made an ordered list one and a list item one, right? And then I went in here and I said make a div with empty props, put in an ordered list with empty props, with a list item with empty props A, B, C, right? So frame 1, frame 2, frame 3, frame 4, and here if I change that one, the actual refresh only has to refresh this one little DOM node, even though I'm sending it a whole tree. So that's the promise of React, and of course there are a number of things you need to do to make that work well with React. But that's what the raw picture looks like underneath. So let's go up and see these functions. You can already see there are a couple things wrong with them. One, the props aren't optional. So like even if I want, if I wanted this to look a little cleaner, well, now I'd have to put in some logic where I'd say, all right, well, if the first thing you passed is a map, right, I could do that, right? I could just say and args, and then just destructure them and figure it out, and this is a bunch of logic. And then every render of everything on my screen is going to have all that conditional logic thrown in it. I mean, it looks nice, it's pretty, but that ends up generating a bit of overhead. And this is where it looks at first like JSX has a leg up, because JSX is a compiler So it can look at what you've done, figure out how to turn it into kind of the most efficient code, and then output the JavaScript for it. Okay, so this takes us to Fulcro. So let's close this raw namespace, close these guys out. I'm going to go over to my shadow CLJS file, and I'm going to tell it, instead of loading raw, let's load app. That's the thing I want to load. And just to get a clean slate after that finishes compiling. Oh, right, app brings in Fulcro, so that's why it was taking a little time to get its initial stuff in order. And this is index now, not raw. And you'll see now if I go to app, where I've got some code pre-written here. And let's get some of this out of the way just as a, well, you see I've kind of pulled some of the things in already. I don't need these anymore. And I'm pulling in Fulcro's DOM helpers that look a lot like the functions we were just using. I clear the REPL here to make things clear. All right. So if I, open a line here and I should see it hot code reload. I do, so that was just a verification that I'm not, going to see insane things. And just for fun, I'm just going to go ahead and do one of these renders and see that, okay, it's working. I can do this create element with raw JavaScript data structures. I can evolve it. I can make something red. Great. All right, let's see how fast that is. So if I try rendering 100,000 divs, so these are updates, but the main overhead here obviously is doing the creation of the virtual DOM tree. So calling this create function has some overhead, and then of course the render has some overhead. So actually we could just measure how long does this raw create element take even when it's not rendering. Okay, so 146, 138, we'll run that a few times, let the browser warm up and make sure we've really got kind of a solid number. So about 135, 136 milliseconds for that many iterations on this machine for this browser. So that's the kind of base level. Now I'm curious if we were to do one of our times of our functions over in raw. Let's actually pull one of those over here. I didn't think to do that in my planning, but it just occurred to me that would be, here, let me undo these so that they are easy to, I don't care about that, but I just want the div one. So this is calling that, so let's just drop this guy in here and call this fdiv. Well, that's a bad name for it. Div basic. Right, so this is our basic idea of maybe how to do a div. And let's go ahead and throw in our convenient version here. Div basic class name red with hello. All right, so let's time that. Oh, sorry, I have to save and let it hot code reload. All right, way slower, right? So even when I try to get it there, I'm nowhere near 136 milliseconds. I'm at a little more, almost 3 times, almost exactly 3 times slower with this naive approach. So JSX clear winner here in terms of overhead for notational convenience. Now, can we do better? And the answer is, yeah, we could do a lot better. So it turns out that Fulcro's DOM namespace leverages Clojure macros, Clojurescript macros, Clojurescript, they're macros. And what a macro is basically it's just a function that you can write in Clojure that runs at compile time, transforms your source according to what you output from the function. So for example, a really simple macro, let's say we call it, oh, this will be fun. Let's just make a function called exclamation point, a macro called exclamation point, that just takes a body. right? Any number of internal things. And what I want it to do is wrap that body in a try, run the body, and then catch default exceptions and do nothing with them. So just basically do this thing, and I don't care if it works or not, but don't tell me about it. So that's the macro I'm going to make. And let's see now. I think Shadow will reload that in this namespace. So now if I come down here to my little comment block and I say macro expand, bang, print line hello, and I have to quote that to see what it would do. I think I have to load that manually. Oh. I think I actually have to do that. Oh, spell it right, Tony. Oh. Can't write macros in Clojurescript. You have to write them in Clojure. So I would have to convert that to CL. Let's just do. I forgot these weren't I usually work in CLJS files where they're both. So let's make a add macros namespace in Clojure here. Macros are, because the compiler is written in Clojure, macros actually are written in Clojure. So let me pull this macro over here. And you know what? I'm gonna, yeah, that's good enough. So over here, okay, that's cleaner. Okay, so now down here, I can macro expand, and you can see now I could use this notation of surround my thing with bang to really mean make a try catch that just catches things and doesn't do anything with them. Oops, and I see an error in my macro, and that's that this needs to be a plain symbol. So let's do that, do this, and there we go. That's what I wanted it to output. So this command just tries to see what the macro would output. So using this notation at the top level, right, so I could actually run this now, and you see hello come out on the console over here. And if I try throwing some sort of exception, oh wait, what is it? It's JS error. Right, I still get hello, but if I'd done that with a do, I'd get an exception. So macros let me kind of reform, like invent my own kind of notations to reform things in a simpler way. Fulcro leverages this to great effect to get us back to what we want for these guys. So I'm going to get rid of this macro bit. I can leave it there. What does it matter? Okay, so div basic, we saw that was slow. Macros, we see those basically allow me to write new notation that rewrites my source code before it actually makes it to the next layer of compilation, which is turning it into JavaScript. Well, I'll leave those there for historical purposes. Okay, so let's look at what Clojure's DOM namespace does for us. And it turns out in Clojurescript, you can actually write both a macro version of something and a function version of something. Because with macros, you can't use macros as a higher order function because they're not functions. So for example, if I went down here, I've still got this exclamation point thing pulled in. If I were to, say for example, just even try to write the expression, I'm just going to make a function here where I try to map over exclamation point, that sort of thing, and save that. It'll tell me no, bang isn't even a thing that exists after compilation, right? It's a macro. It's just not even there. but I very well might want to map over a div and put various things in them. Right? And it turns out Clojurescript allows it can auto figure out that if you use div as a function, it should use the function version, and if you use div in a different context like that as a invocation, it should use the macro. So let's see what we get with that. So if I say macro expand div hello, right? So this is the Fulcro thing. These are kind of generated by code. I've got macros that generate macros that also generate functions. So this namespace is actually relatively short, and it just lists all of the possible DOM things that you might want, and then it uses generators to generate the, it's fairly involved, but the idea is to try to get as good a performance as we can get. So let's macro expand div of hello, and we can see this calls a function called macro create element star. So let's go look at that one. Macro create element star, and so this is literally just create element, and it takes an array, so it uses apply here to use the array. So and it's sending nil into side concern, but that's what it takes to make it work. And notice the macro has already pre-converted the arguments into JavaScript. Same thing if I put a map here and say class name red, and I macro expand that, it magically outputs source code that's exactly what I want for this to be essentially full speed, because I just have this one layer of function call overhead, and the optimizations in the compilers in JavaScript, the runtime interpreters that are just-in-time compilers, can pretty easily optimize away kind of redundant function call layers and that sort of thing, and make things pretty fast. So you can see I'm already getting pretty good leverage out of this macro, and in fact, if now I change this to Fulcro's div and run this, you can see nearly identical. In fact, if I run that a few times, right, it's averaging 138 to 140, 139, 134, right, just like maybe a % faster, kind of hard to tell, but you'll see, if I run that enough, it's a little slower, but so much little slower. That's 100,000 calls. Having 100,000 elements in your DOM is it's not impossible, but for most screens that's a lot. That would be a lot of elements. And so a 1 millisecond per 100,000 overhead, and this is a 2013 laptop that we're working on here. This is not a brand new machine, so the difference is tiny. Now, I do want Fulcro users to understand that you don't always get this optimization, and you can very easily confuse, or make it impossible rather, for the macro to know what to do. So one way to do that is to just say div with a symbol, because this symbol could be a props map that's a Clojure data structure which needs to be converted to JavaScript, or it could be a child, right? I could have defed a to be a list item, right? I could have defed a to be props. I could have defed a to be a string, and at compile time I don't know what a is. And so if you macro expand that, it calls a different function. Notice there's no star on this, with plain Clojure data, and so that's going to have some overhead. So if I take this guy up, right, and I've got a defined up here just as a string, if I take that guy up and put it in here and run that, you'll see it's slow again. And it's slow because it's having to do runtime interpolation of the arguments to figure things out, and that can only be done by a function. And so there's no way to do these fancy things. Now, as soon as I throw a map in here, it gets fast again. And it gets fast again because it's unambiguous. Div, the macro, looks at it and says, oh, well, the first thing's a map, and so that's a child. I don't know what the child is, but I know it's going to be a child, and so I can go ahead and emit the star version and convert this to a JavaScript array of things and a JavaScript map of properties, and then run something to force. The force children is about lazy sequences. If you were to embed a lazy sequence as a child, you'd have a potential problem. So the macro automatically takes care of you being able to say, map over div a, b, c, that sort of thing, because this map's going to return a lazy sequence, and so this force children unmakes it a lazy sequence, basically recursively. Okay, so we can see that that's one way of getting your performance back. Now notice, even without the map, it's pretty darn fast, right? That's 100,000 iterations per element. So 250 milliseconds divided by 100,000, right? What is that, 250 microseconds shifted over 2 microseconds per call versus 1.5 microseconds per call. So we're talking about extremely small differences that can make a difference on a fairly large page that's changing in large ways. But I just wanted you to understand that this is a superpower. I don't need a separate JSX plugin for my build system that then turns it into the thing that the compiler really wants to see. I've got that power built into the Clojurescript ecosystem because it's just part of the language. It's part of the language to be able to morph your thing, your call, from one thing to another via macros. So this is an example of a fairly complex use of a macro. I'm doing a lot of different things here. I'm supporting the idea that you might want to, let's go down here and render some of these. So if I render this to the screen, I get these items. I can add a class with this funny notation that's just convenient, right? I don't have to write the whole map of things. I don't have to say, items is a regular function. Sorry, items is just this function that does an OL with a map indexed, making list items with the proper React key. And let me stay on topic. I thought something else to say there, but so there's some notation here where I could say class name red, right, and render that. But for fun, it's nice to be able to do this. Now, we run into an interesting conundrum here is when we macro expand that, the compiler still can't guess, this macro can't guess if A is props now or a child, because some nodes like input, that would just be props. But with div, it could just be props. You could just making a div with like a width and a height and a color and that sort of thing, and so it can't know. So it uses the non-asterisk version, right? So that one's going to be slow again. To fix it, all you have to do is add in props, so then it's unambiguous, right? And you don't even have to use a map. You can use nil if you want, and it still gets the idea that I can use the fast version and pre-convert all the data structures because it's unambiguous. So if you want the absolute fastest DOM rendering in Fulcro, you can get native React speed just by keeping your usages unambiguous in terms of what the props are and what children are. And so that can be as simple as, right, the keyword has to be a keyword if you use it. So you could say .red wide fat thing, right? That's multiple classes that it would add, and as long as there's something that it can know, all right, that nil, obviously nil can't be an element, so nil must be props, because props can be nil, and a map can't be an element, so that must be props, and so that's unambiguous. You get the star version. But as soon as you drop the props, you don't get the star version. So that's kind of your overview of how Fulcro gets full speed native React JSX style speed out of DOM creation, and gives you kind of the power to, with some extra notational convenience added in, you can quickly add classes or IDs, right? The ID of that node, so I can come up here and render. Where's one of my render examples here? All right, so if I go and inspect that element, you can see that it added ID thing to it, class red. And if I macro expand that, you can see that this special notation got converted into low-level React JavaScript props for direct calling against React right there. That happened before the hot code reload ever happened, before it ever reached runnable JavaScript. Okay, so then I did want to mention just one more thing about how React works in terms of this key idea. Hopefully you're an experienced React developer and you fully understand key, but you may not. You may be surprised to or maybe you won't be. Hopefully you won't be. So if I go and manually make this thing that I'd shown earlier, do I have a render of that? Nah, but we can just render this guy. Let's comment this guy out and say I want an ordered list with a list item of A and B. I'm going to make sure you can see the console here, and if I render this onto the root, you notice I got no warnings, no errors, no problems. If I map over the li as a function, A, B, I do get a warning. And so this is the basic statement of keys. If it's obvious from this, like the children are just kind of static parts of the DOM structure, there's no need to tell React anything else about them because it doesn't expect them to move around or change. But as soon as you pass it something that looks like an array, right? So map becomes a lazy sequence, and you saw in that macro expand wraps that with a forced children, so the lazy sequence gets unwrapped, and then that gets turned into a JavaScript array. When React sees that JavaScript array, it says, oh, you're sending me something you're programmatically generating, and you're probably going to move those around or edit them or whatever, and when I need to go edit the DOM, I want to be able to find the right one quickly so that if like one disappears, I know which one disappeared, that kind of thing. Or if one gets edited, I can tell which one to go and edit without having to like figure out, did you reorder them? What did you do? And so this warning says, all right, I'm going to make my best effort at rendering the list, but if you do multiple frames here, it's going to potentially look screwy. I'm going to get confused and maybe render it wrong, or at the very best, it's going to be slower than it needs to be. So you can get away with this kind of warning, but the better thing to do is to make this a function. And here we can say map indexed so that we get an index into the list. This is kind of the recommended thing if you don't have a known unique ID on each element. And maybe I should call this label for clarity. Right, so I have my lambda, which calls li to make list items with a React key of idx and a child of label, and the two labels. Now I'm going to reload this because React will only give you this warning once about a particular area of the DOM, so I'm going to clear out the DOM, rerun this, and we'll see we get no warning. So that's what key is about, is it's just putting a unique identifier on siblings. But the thing that a lot of people don't understand is it's a generated list or an array of things where React is detecting that, oh, you're generating that from a code algorithm, and therefore it's going to change in a way that I need to understand better to make it fast. Okay, so that is the low levels of React and how Fulcro can generate these React DOM elements to be as fast as native code.